Namaste, I am Amba Kulkarni. I am professor at the Department of Sanskrit Studies, University of Hyderabad, and I will be teaching part of this course on Samsadhani Praveshika. We are a team of 4 members. I will be starting the sessions, and later on my other colleagues, Professor Dr. Arjun, Dr. Pavan Kumar and Professor Gerard Huet from France will be joining with us. Today we are going to start a new unique course titled Samsadhani Praveshika, Learning Sanskrit Using Computational Tools. Now, before starting anything on Samsadhani, Samsadhani is a special platform developed at Department of Sanskrit Studies, University of Hyderabad, to learn Sanskrit. This is a special platform for learning and teaching Sanskrit, and of course doing computational analysis and other things. But in this particular course, we are going to concentrate on only the aspect of this toolkit or this platform where we can use it for learning Sanskrit. And before going into that particular platform, first I would like to give an introduction to India's contribution to the language sciences. Now, why it becomes important is because these language sciences provide us the theory for developing this computational platform. Language, as all of us know, is a means of communication, and communication is a two-way process between a speaker and a listener. Speaker expresses their thoughts through a language string, and listener deciphers that language string into thoughts. Indian civilization is the only civilization that developed these theories of verbal communication. Verbal communication, which is, I said, two-way process. So, there is a process that is going on in the mind of a speaker of converting thoughts into a language, and there is another reverse process that goes on in the mind of a speaker of deciphering a language string into the thoughts or into the concepts that are involved into it. India has a very great contribution here. As I said, Indian civilization is the only civilization that developed these theories to a very great detail. The other civilizations also dealt with languages, but it is the Indian civilization which gave the theories of verbal communication for both the speaker as well as the listener. Of course, these are the models. It's not that actually when speaker speaks something, these things are happening in his mind, but this model is something which is computational. Panini's grammar deals with converting thoughts into a language. It gives a model for these conversions, and the theories of verbal cognition, which are called Shabda Bodha. Bodha is understanding. Shabda is derived from the word Shabda. Shabda means word. Shabda means related to Shabda. So, the theories of understanding that are related to the understanding of the words, these are the theories of verbal cognition. And here the main focus is on deciphering a language string into thoughts. So, how do we understand a language string? This is the main topic of these theories of verbal cognition. Okay, so why these theories were developed? Why Panini developed the grammar, or why these theories of verbal cognition are developed in India? Main goal was to protect the Vedas. These Vedas, as we know, were transmitted orally from one person to another, from Guru to Shishya. Now, there are two things that needed to be protected. One, the content of the Vedas themselves, that is the words, and for this they developed various techniques, and these are called Vikrutis. Ashtavikrutis were developed and Vedas were chanted following those Ashtavikrutis, so that there is no disturbance, there is no deviation from the original sequence. That was the main purpose. The other thing that also developed during this time was development of various sciences. These are called Vedangas, Veda Anga. These Anga means the part or limbs of the Vedas, that which are the ancillary texts or the texts which are useful for understanding the Vedas. These are not just the texts, but these are the theories or the sciences that were developed. And what are they? These are called Shiksha, Chanda, Vyakarana, Nirukta, Kalpa and Jyotisha. Now the Shiksha Shastra, it deals with phonetics and phonology, more of phonetics. How the sounds are pronounced, what is the method of pronouncing, what is the place of pronunciation, how much effort is needed to pronounce a particular phoneme, etc. These are dealt in Shiksha Shastra. The second one is Chandas, which deals with the prosody. As all of us know, these Vedas, these are the mantras which are written or set to various chandas, various metrical patterns. So the study of these prosodies, the science that deals with the prosody, is the Chanda Shastra. Then there is a Vyakarana, which deals with the grammatical aspect of a language. Nirukta deals with the etymology of the words, specifically the words from the Vedas. Kalpa Shastra deals with the geometrical patterns and Jyotisha deals with the astronomy. So as I said, all these 6 sciences were developed in order to preserve the Vedas. Vedas deal with various things. One of the major thing that is dealt in Vedas is performing the yajnas, various rituals. So while performing the yajnas, they needed various astronomical data, and the astronomy was developed. Then while performing the yajna, they needed certain patterns, certain shapes of these Vedic altars, and there the geometry got developed. In fact, if you look at the geometry that is discussed in the Kalpa Sutras, you will find various methods of drawing a square, drawing a circle, say with how to get the value of root 2, because they were interested in drawing a square whose side is equal to the diagonal of a unit square. Similarly, they were interested in drawing a circle whose area is approximately equal to the area of a square, and so on. So various formula for pi, all these various geometrical constructions and the constants that are involved with geometry are found in Kalpa Sutras. Okay, so among these 6 Shastras, we see that first 4 deal directly with the language. Shiksha Shastra deals with phonetics, Chanda Shastra deals with the patterns of verses, the metrical patterns, Vyakarana Shastra deals with the grammar, so the syntax, how the words are formed, how the sandhi takes place between 2 words, how to get the meaning of compounds and so on. And Nirukta deals with the etymology of special Vedic words. Among these, Vyakarana is something which is very important, because Vyakarana is the one which tells you various things related to language, like word formation, how the words are to be joined together, when the words are joined together, how they undergo special phonetic changes called sandhi and so on, how to get the meaning of a sentence, how to get the meaning of a compound. This Vyakarana is very much important, and you will also see that the importance of this influence of this grammar is throughout all our Indian scientific knowledge systems. In fact, the philosophies, if we look at, there is a quote which I would like to refer to. Daniel Ingalls, in his article on comparison of Indian and Western philosophy, says, I quote, the mathematical method is characteristic of much of a Western philosophy, whereas the grammatical method is characteristic of much of Indian philosophy. So, you see here in the West, it was mathematics, and that became the basis of all scientific and philosophical knowledge systems, whereas in India it is the grammar which provides a strong base for all the scientific knowledge that exists in Sanskrit. So, naturally the study of grammar becomes very important in order to understand any text that is written in Sanskrit. Now, the question is, why learn Sanskrit? Well, various people have different goals, different reasons for learning Sanskrit. For me, learning Sanskrit is important because in order to understand any Sanskrit text in origin, we need to learn Sanskrit formally. And why we need to read the Sanskrit text in origin? The reason is, well, many of the important Sanskrit texts are translated into English and many other languages. Even in Indian languages, almost all imported texts are translated. And not only English, but in many languages of the world, important texts in Sanskrit are translated. But then, when we look at the translation, we still have a kind of doubt in our mind. Is it the same thing that is written in Sanskrit, or how is it expressed in Sanskrit? Or we might be interested in knowing and feeling the beauty of that language itself. Say for example, let us take the classic Gitanjali of Rabindranath Tagore. Even though I read the translation, I always feel that, oh, I should read this in origin. Maybe I will get a better experience, better understanding of the original text. Further, since for the Indians, most of the Indian languages are derived from Sanskrit, there is lot of common vocabulary, common syntax, etc. So, for Indians at least, it's just a matter of learning few things, few grammatical nuances of Sanskrit in order to understand Sanskrit texts. Now, main problem that comes with Sanskrit, learning Sanskrit or understanding Sanskrit, as is the case with any language for that matter, is we need to learn the script, we need to learn the vocabulary and so on. So, here let us see what all is involved in language learning. Learning a language involves learning script, learning pronunciation, learning spelling, learning the vocabulary, learning the word formation, which is called morphology in the linguistics, Western linguistics, learning the sentence formation, which comes under the syntax, then learning the segmentation. See, especially this is very important for Sanskrit, because we need to identify the word and sentence boundaries. We do not know where one word ends and where the other word starts, or where a sentence ends and another sentence starts, because it's an oral tradition. Since Sanskrit is influenced by oral tradition, the segmentation becomes an important aspect, and unless we understand the segmentation of a given text, unless we segment a given text into various small parts, we cannot understand the text. Then another important aspect is the semantics, where we understand the meaning of words, understand the meaning of compounds, understand the meaning of sentences, and then comes the understanding the discourse. Once we know the sentences, how these sentences are joined together in paragraphs, how the paragraph gives a new meaning, how the consecutive paragraphs give you further new meaning, and how the complete text gives you some moral or some new information. That is what is involved in learning a language. And of course, there are many more things. Finally, it is also the cultural background that indeed is needed in order to understand the communication. Now, the question is, when we have so many things to learn, and it is said that grammar is taught for 12 years. In the grammar, of course, many of these things are involved, like pronunciation, script, spellings, vocabulary, morphology, syntax, and so on. So, if naturally we don't want to spend 12 years, can we make it 12 hours, or if not 12 hours, at least say 24 to 40 hours, can we get a gist of Sanskrit within such a small span of time? That is what whole exercise is about. And from that point of view, we tried to develop various computational tools in the Department of Sanskrit Studies, and this is something which I would like to now make a point to. Our aim is to learn a new language, but at the same time we know our mother tongue very well. Now the whole effort here is to reduce this language barrier. Can we reduce the time taken to learn a language? Now how do we measure this time, the distance between two languages? Suppose distance between two languages I define as the time taken to learn L2 given that person knows L1. L2 is Sanskrit, L1 is your mother tongue. So goal is to minimize the distance between L1 and L2 as much as possible. So what is the strategy? Strategy is man-machine combination. So it's not just the human being who is learning. Human being is assisted by a machine and we are sharing the load. So the man and machine are sharing the load between them. For example, machine takes the load of rote memory and logic. So whatever is to be memorized, wherever logic is involved, all that part is done by the machine. And the human being takes the load of handling word knowledge, handling the common sense, or he looks at the cultural knowledge, the culture involved with L2, or the domain knowledge, because the same text in some other domain knowledge, some other domain, same word may mean different. For example, the word cricket. Cricket in the field of sports means a game, but cricket is also an insect if you are talking about the insects. So the same word may mean different things in different domains. And all this load of handling the word knowledge, handling the domain knowledge, handling the cultural knowledge or the common sense is taken by human being. Now it is something like when it comes to Sanskrit, in Sanskrit you know that word formation is very important. The suffixes are added to the stem and a word is formed. So unlike English or Hindi, where you have something like by the man, to in the house, where in, to, by all are separate, in Sanskrit you will have these suffixes attached to the stem itself. So you will have something like Ramena, Ramasya, Ramaya, Ramat and so on. So we need to memorize all these forms, but now with the help of machine can memorize this. So it is something like in the old days we used to memorize the multiplication tables, but now this new generation does not memorize these multiplication tables, they just use the calculators for that purpose. And all other mathematical process, taking decisions etc. is done by the human being, but the calculations are done by machine. Similarly here we would like to have a kind of sharing the load between man and machine, where some part of the language which is kind of mechanical, which involves rote memory, which involves normal logic will be taken care of by machine, and the remaining where we do not know yet how machine can handle this, human being will be dealing with that. So if we say that now there is a man-machine combination and we want to reduce the time taken to learn a language, let us see for Sanskrit how much work has been done so far. So, as far as the scripts are concerned, now we know that Sanskrit is not written just in Devanagari script, but if we look at manuscripts, Sanskrit is written in various scripts, the old scripts such as Grantha or Sharada Lipi and so on, and even the modern scripts like Telugu or Kannada, Malayalam. You will find a lot of manuscripts in these various scripts, and to a certain extent, the script problem is 100% solved. Now, I say to a certain extent because if we are dealing with the actual manuscripts, machine cannot read those manuscripts directly. But suppose some text is entered into machine in say Bangla script, I can automatically convert it to Devanagari, or if something is in Devanagari, I can convert it to Telugu script and so on. This conversion is possible. As far as the pronunciation is concerned, again, we do not have any help from the machine side, in the sense that machine cannot take the dictation. I cannot just speak in Sanskrit and machine types it for me, or machine cannot speak Sanskrit for me. Whereas for English, we have these dictation machines available, or we have this Google lady who helps us in following the map. She speaks for us, she gives us direction in speech, but such things are still not available for Sanskrit. As far as spelling is concerned, since Sanskrit is written in a way, the way Sanskrit is spoken and written, there is hardly any discrepancy. The way it is written is the way it is spoken. So, we do not have to remember the spellings as such. We do not need this module for remembering the spellings, whereas in English, the spellings are different for different words. The pronunciation is something and spelling is different. There is no one-to-one mapping, whereas for Sanskrit it is not the case. Then we have several online dictionaries. Over the period of this course, we will be looking at various dictionaries. Some dictionaries are already integrated in the Samsadhani platform. Some of them are not integrated, but they are available on other platforms which we can make use of. As far as the word formation is concerned, the words which I was talking about, Ramena, Ramaya, Ramat, these are the various forms of the word Rama. And machine can not only generate these forms, but also can recognize. That means, if I give a word to a machine, machine can analyze it and tell me what is the suffix, what is the stem, what is the pratipadikam, what is the suffix that is attached to it, and what is its meaning. All these things machine can tell us. I said 95% the word formation works, or the word analyzer works. Why 5% difference, the reduction? The reason being, there might be certain words which are not in the dictionary, or there might be certain words which are newly borrowed from some other languages and are being used in Sanskrit, or there might be some new words which are coined very recently. Such words will not be there in the dictionary, and therefore our machine may fail to analyze these words. As far as the sentence formation is concerned, or sentence analysis is concerned, 60 to 70% of the sentences machine can analyze on its own. And then for the semantics and various other tasks, the work is still going on. So, at least till syntax, machine can help us a lot in understanding the text. So, with this background, now we will look at the script first. In today's talk, I will first explain the Sanskrit script, the complexity involved in the Sanskrit script, and after that we will have a demonstration of some of the features related to script from the Samsadhani platform.